Section 3.1 Algorithms. An algorithm is a finite sequence of precise instructions for solving a problem. It has these 7 characteristics. We use pseudocode to describe algorithms. The pseudocode is presented in Appendix C of the textbook. Here we'll briefly go over the operators of pseudocode. It contains variables. The names of the variables are strings of letters and numbers. And we can think of variable as a pointer to a place in the memory where the value of the variable can stay. We have this assignment operator. X and y are names of variable. So if we already have a value assigned to y, we can use this assignment operator, and it takes the value of y and assign it to a. That is in the memory separated for x. The value of y is written there in that memory. The value of y doesn't change, so in y we still have the old value of y. The next operator is if statement. It has this form: if condition, then action. Condition is some proposition. If that proposition is true, the action is taken. The action can be a single operator or a sequence of operators with the same intention. If the condition is false, then the action is not done. Return statement: return x. This operator produces output x and terminates the algorithm. We consider this example for finding the maximum of 3 numbers. The input consists of 3 numbers, a, b, and c. The output, it is the value of the variable large. And in large you'll have the largest of the 3 numbers. First row, max 3, a, b, c. This max 3 is the name of the procedure. A, b, c is the input. The next row, large takes the value of a. Then we have this if statement. If b is bigger than large, then large will assign the value of b to large. The next statement is if c is bigger than large, then we assign the value of c to large. Return large. It is clear that after each line, after each operator is executed, in large we have the largest value of the first several numbers. In the beginning, in large we have the largest value of A, which is A of course, and the first if statement is executed, in large we have the largest of A and B, and after the second if statement is executed, in large we have the largest of the numbers A, B, C. The next operator that we consider is for loop. For loop has this structure: for variable, initial value to limit action. The action is executed for the following values of the variable: initial value plus 1, and so on. So all integers from the initial value up to the limit value. In this example, we present a procedure that finds the maximum value, the largest value of the numbers A1, A2, and so on, AN. Procedure max A1 and so on, AN is an integer sequence of length n. First line, n takes value A1, for loop, for I from 2 to n, and this is the action of the for loop. It consists of this if statement. If A sub I is greater than n, then n takes value A sub I, returns n. Show that the algorithm is correct by proving that the statement n is the largest value in the subsequent A1, A2, and so on, A sub A minus 1, is a loop invariant. In the beginning, I is 1, and when n we have the largest value of this subsequence A1 only. Then when I is 2, if statement is executed in the for loop, and if A2 is bigger than n takes value A2. So after the execution of the action of the for loop, for I equals 2, and in n we have the largest value of A1, A2. After the action of the for loop is executed for I equals 3, in n we'll have the largest value of A1, A2, A3. So this statement is loop invariant because it is kept true for each I from 2 to n. And at the end, we will have in n the largest value of the sequence. The next operator is this while loop, while condition action. If the condition is true, the action is executed once, and the condition is checked again. If it is true, the action is executed once again, and this continues until the condition becomes false. Then the while loop terminates. In this example, we consider the linear search algorithm. The input is a sequence of length n of distinct integers. First, I takes value 1, and then we have this while loop. The condition is I less than or equal to n, and x different from ai. While this condition is true, the action is done. I takes value I plus 1. If I is less than or equal to n, then location is equal to I, else location is equal to 0. Return location. In the beginning, I is 1. The while loop terminates when the condition fails. The condition can fail if I becomes greater than n, or if x is equal to a sub I for some I. And at the end, when the while loop terminates, we check what is the reason for termination. If the reason is that if I is still less than or equal to n, then the loop has terminated because this condition fails for some I, which means that x is equal to some I, ai, and in I we have exactly the location, the value of I for which this happened. Else, this means that this is not true, that is I is greater than n, and that means that x was not found. So we assign 0 to the location variable. So if the output is 0, it means that x is not found. Otherwise, in location we have the position of x in the sequence. In the next example, we have a bubble sort algorithm. The input is a sequence of length n greater than 1 of real numbers, and the bubble sort consists of two loops. The outer loop takes values for values of I from 1 to n minus 1, and this is the action of the outer loop. It is just the inner loop. For j from 1 to n minus I, the action of the inner loop is this if statement. If a sub I is bigger than if a sub j is bigger than a sub j plus 1, then interchange a sub j and a sub j plus 1. Return the sequence A. This is the output. In A we have the sequence sorted. We consider this input to see how the algorithm works. The input sequence is 8765. use the bubble sort procedure to sort the sequence A in increasing order. The length of the sequence is 4 because we have 4 numbers in the sequence. And the outer loop will be executed for 4 minus 1, 3 times. So we have 3 passes for I. When I is 1, the inner loop is executed from 1 for values of j from 1 to 4 minus 1, 3. So j will be executed, will take 3 values. When j is 1, in the sequence we have these numbers. Then the if statement is executed. A1 is A1 bigger than A2. In A1 we have 8, in A2 7. This is true. Because the condition is true, we have to do this interchanging. It is swap the values here, and the sequence becomes this. Then the inner for loop is executed for j equals 2. If A2 is bigger than A3, and this is true, in A2 we have 8, in A3 6, 8 is bigger than 6, interchange those members of the sequence, so the sequence becomes 7, 6, 8, 5, and j is executed, the inner for loop is executed for j equals 3. Is A3 bigger than A4? This is true, because the condition is true. This statement is done. The action of the if statement is done. Swap 8 and 5, we get this. So after the first pass for I, in the sequence we have 7, 6, 5, 8. You see that the largest number is on its correct place. 8 is in the last position, and the subsequence of the first 3 numbers needs to be reordered. The second pass is done for I. So this I takes value 2 now. The inner loop will be executed for I equals 2, which means that j will take values from 1 to 4 minus 2, from 1 to 2. When j is 2, and for I equals 2 we have this sequence. J is 1. Is A1 bigger than A2? It is true, so they must be swapped. Then j is 2. Is j2 bigger than, is A2 bigger than A3. It is true, so they must be swapped. And we are done with the second pass. After the second pass for I, in the last two positions we have the correct values, the largest two values are there. And finally, the third pass must be executed for I. When I is 3, this is what we have in the sequence, and j must vary from 1 to 1 here, because 4 minus 3 is 1. So the inner loop is executed only for j equals 1. Is a1 bigger than a2? It is true, so they are swapped. And all 4 loops are executed, and the sequence is in increased order. The next example is a binary search algorithm. This is the procedure. The input is a sequence of lect n of integers in increasing order, so the sequence is already sorted. The input is sorted. X is an integer, and the algorithm has to determine if X belongs to the sequence. I takes value 1. This is the left-hand point of the search interval. J takes value n, the right-hand point of the search interval. While I is less than j, this action is done. N takes value the floor of I plus j over 2. This is approximately the midpoint of the interval. If x is bigger than a sub n, then I takes value n plus 1, else j takes value m. That is, the search interval is corrected. At the end of the while loop, this if statement is executed. If x is equal to a sub I, then location is I, else the location is 0. So let's see how this algorithm is executed for this input. Sequence of length 8, already sorted, and x is 3. So we're looking for the number 3. Is this number a member of the sequence? So we'll form this table to trace the algorithm for this input. A column for I, j are variables that appear in the procedure. I less than j is a condition here, so we'll write a column for that. A column for I plus j over 2, a column for m, a column for this condition is greater than a sub m, And then we have a column for the condition of this statement, x equals a sub I, and a column for location, the variable location. So I start from the beginning. From the input we know that x is 3, and these are the members of the sequence, and the value of n is 8, the length of the sequence. For I, first I takes value 1. In the beginning our columns are empty, and then we start to fill them out from the execution of the algorithm. I takes value 1, j takes value n, which is 8, and then we arrive at the while loop. Check the condition of the while loop. 1 is less than 8, so the condition is true. We do the action of the while loop once. N takes value, the floor of I plus j divided by 2. In I we have 8 plus 1, 9, divided by 2, 4.5. The floor of 4.5 is 4, so n takes value 4. And then we arrive at the if statement. The condition of this statement is x greater than a sub m. But x is 3, a sub m is a sub 4, it is 5. So we have this condition, 3 greater than 5, it is false. So we don't do this statement, the statement after them, we do the statement after else. J takes value m. J takes the value of m, which is 4. So I have these values, 9j now, 1 and 4. We check the condition of the while loop, I less than j. 1 is less than 4, it is true. So the action of the while loop executed one more time. I plus j divided by 2 is 2.5 now. 1 plus 4, 5 divided by 2, 2.5. And m takes value, the floor of 2.5, which is 2. Then the if statement comes, is x greater than a sub m. 3 greater than a sub 2. A sub 2 is 3. 3 greater than 3 is false. Because the condition of this statement is false, we do the operator presented after else. J takes value m. J takes value m. The value of m is 2, so j becomes 2. The action of the while loop is done. We check the condition of the while loop again. I is 1, j is 2. Is I less than 2? Is I less than j true? 1 is less than 2. So the action of the while loop must be done one more time. I plus j divided by 2 is 1.5. The floor is 1. M takes value 1. Now this statement. X greater than a sub m. 3 greater than a sub 1. A sub 1 is 2. 3 greater than 2 is true. because the condition of the if statement is true, we do the action after then. Location takes value I. Location, over here. We do the statement after then, and it is I takes value m plus 1. I takes value m plus 1, and then in m we have 1, so I takes value 2. The action of the while loop is done. Now in I we have 2, in j we have 2. The condition of the while loop is false. 2 is not greater than 2. So we're done with the while loop. We do the next statement, which is this if statement. The condition x equal a sub I, x is 3, a sub I, in I we have 2, a sub 2 is 3, so this is true. Because it is true, location takes value 2, and we return, the algorithm returns location, which is 2, and in A2 we indeed have the value 3, the value of x. So the correct value of x is found.